Hello, I'm Lala, and today I will be explaining how to solve a system of equations. So here we have a vector equation, and I'm going to teach you how to break it down into a more simpler matrix that will help you find its solution set. So we're going to start off by combining these vectors into a matrix. And all you're going to do is get rid of those variables and put them into a, what would it be, 4 by 6? Yeah, 4 by 6 array. So I'm gonna take these numbers, write them here. Variable 2 is 2, -3, 0, -1. We have 2, -2, 0, -2, -3, 3, 0, 3, -1, 3, 1, 3, and I'm going to put this bar here. That's just going to separate our actual equation from the solution that it's set equal to. So 1, 2, 3, 8. I'm just going to close that off. All right, so now that I have this arranged into a matrix, I'm going to do a calculation called RREF. And that is simply just row reduction. It basically means you take these operations and you construct this matrix into a simpler one, and I'll show you what that looks like. So I have already done this calculation for the RREF matrix, so I'm going to go ahead and write that down. Bar and 2, 1, 3, 0. Okay, now I'm also going to mark these ones, and these are called pivots. So a pivot is your upper leftmost variable or input is a positive 1. And that just means everything above it and everything below it will be 0. So here we have 1, 2, and 3 pivot columns. So if you would look closely, these 2 columns do not have pivots. So we're going to call those free variables. A free variable just means that that number, or whatever number you're going to put there, is free to be any real number. So I'm going to go ahead and circle these. Okay? All right. So we start off, we have x1, x2, x3, 4, and 5. So these just represent x1, 2, 3, 4, and 5. So as we look closely, x3 and x4 are free to be free variables. So I'm just going to rename them. x3 I'm going to call A, and x4 I'm going to call B. So those two, the A and the B, are free to be any real number. Now, I'm going to take this matrix, this RREF matrix, and I'm going to write these equations out based off of the numbers that classify each variable. So for example, the first row, this is x1. So I'm going to write x1, there's 0, x2, so I'm just going to skip over a little bit. We have -2, x3. We have a +3, x4, 0, x5, and then equals 2. Okay? So now I'm just going to do that for the next 2 rows. So I have 0, x1, I have 1, x2, I have +2, x3, I have -3, x4, no x5s, and it equals 1. In our third row, we have 0, x1, 0, x2, 0, x3, 0, x4, but our x5 equals 3. Okay? And now, I'm going to switch colors really quick. And just because right here we named x3A, I'm going to go to these 2 x3s, and I'm just going to rename them A. And then x4 we called B, so I'm going to substitute a B. Okay? So now we have, these will simplify to our solutions. However, we have to solve for our variables. So for example, the first row is going to be x1 equals, so this -2 is going to turn to a +2. So I have 2a. That +3b is going to turn into a negative, so -3b, and then +2. So this is the solutions for x1. All right, x2 equals, this +2a is going to turn to a negative, so I have -2a. -3b is going to become a +3b, and then +1. Okay, and x3 we said was A, x4 we said was B, and x5 is already solved for us, it's 3. Okay, so here is our solutions. However, we have to write them into a solution set. So a solution set is just taking it and putting it in braces. So we don't, in our solution set, we do not write the x1 equals, x2 equals, x3 equals, and so on. We just write this, simply just write the solutions. So I'm gonna write, for the first row, I'm gonna have 2a minus 3b plus 2. Second row is gonna be negative 2a plus 3b plus 1. We have a, b, and 3. I'm just gonna close that bracket. However, I have to state that a and b are free to be any free variable. So I'm gonna do that by putting a bar. I'm gonna say a and b are in all real numbers. And that just means that they're free to be any real number. And this is our final answer. Okay, and I hope that this video helped you to understand how to solve assessment equations. All right, thank you.